Okay, now we can start. By the way, just an administrative notice. Today we're going to have a slightly shorter session because I'll be here until 9 o'clock and not until 10 o'clock. Okay. So, good for you. Okay, we're going to talk about classes and objects, and since the last since the last lesson, I already told you I'm very glad we were talking about recursions, because recursions are awesome, and we're already starting to talk slightly more geeky language, and we're getting more into the basics, into the building blocks of C# and its power and what it's really consists of, and how to start thinking in object-oriented on your program solutions. And that's good. We've already covered methods, and today we're going to start looking at classes. Mostly we're going to look at them from the outside. We'll look a little bit on the inside, but there's going to be another lesson, I think 2 lessons from now, which are going to cover better the inside of classes and building your own. But for now, we're going to start talking about this concept, which is a very important concept and very strong core in C# and in other object-oriented languages like C++ and Java. Although the implementations of this whole mechanism, of this whole architecture, is slightly different. Whoever used C++ before, it's close, but it's different. And this is the building block of every part. In other languages, when you can define classes, you don't have to define classes all the time. But C# is built completely on classes, and everything in C# is classes, and that's why it's important to get to know this important concept. So we're going to see what are classes and what are objects and how they relate to each other. We'll see a declaration of a class. We'll talk about fields, properties. We'll talk about the constructors. But we're going to pass through them quite fast through all these. I mean, we're going to see them like in an overview, let's say an introduction to these terms. And I'm sure that starting from today, we're going to see them deeper and deeper in the future. And they're going to be taking a central part in every program that you build in C#. Then we're going to talk a little bit about structures, which are actually classes, just with a little bit reduced kind of classes. It didn't say here, but we're going to talk about enumerations a little bit too. And then we're going to see namespaces, and we're going to see an example of a random string generator class. That's going to be one class that we're going to see the inside of. And then we're going to talk a little bit about the common type system and how types are defined in C#. Most of the things that we're going to see today, we've already seen, and we just didn't all the time call them by their names or understand exactly how they're structured. So many of these things and many of the examples are going to be quite trivial to you, because we've seen them all. Just we're going to dive deeper into the contents. So objects and object-oriented design and object-oriented programming, and this whole world of objects, which is so important in the object-oriented languages. So what are objects? Objects are modular pieces of the software which come to model real-world items, objects. So it could be a person. I can represent a person in my software, and many times I have to represent a person in my software. For example, if I'm a user of a certain software, or if I'm a user of Windows, or if I'm a Facebook user, then I have a name, and I have fields like first name and last name, and I have my age, and I have my height, and sometimes I have a picture stored for me. If we look at other examples, it could be a bank, that anything that can represent a specific bank, or an account in the bank, or a customer, or a car, or a bicycle. These are real-world objects, and when we break them apart, we just see that they have certain properties that define them and certain functionalities that define them. And working with classes and objects in the programming world tries to build on that model, tries to imitate the real-world objects into software. Because many times the programs need to work with objects which really refer to real-world things, and sometimes not. Many times it's some kind of more abstract things. But it's not just that we have a class and it has its properties. There is a whole system of building them and referring them to one another. They can be inheriting from each other. There are other types of classes like abstracts and that we'll see later. We'll see also in the future interfaces and how they relate to that. But the basic of all this is the class and the object, and that's what we're going to see. So I don't think we have any more here. So here's an example of things that could be represented in a class or in an object. We'll see the difference very shortly. So it could be things that are really referring to the real world, and it could be things that we are storing in our class which are not really referring to the real world, but they are important for us to store them because we need to process some data. Because in the end, once we are programming something, it's usually in order to process data, and we need to store this data somewhere, and that's let's say 90% of what computer programs would do in any way. So this is the formal definition of a class. Well, it seems like formal definitions now come from Google. But okay, I don't know. I'm not sure what is a formal definition, because different implementations have their own documentation, and if we're dealing with C#, then most probably we'll find more in the MSDN library than other places. So the idea is that a class, which is the basic building block of everything in C#, is like a template. It's like a mold that we can take and build our objects according to. Working. So the class is the template that we will build our. So we can say, for example, person. That would be our template. But if I refer to a specific person that already has specific properties, so I can say a person has an age, and an age is a number. So that would be in the class. Once I instantiate, once I create using this class something, I have to provide some real data into it. And that means a certain person has a certain age. So the classes define which properties our objects will have. We'll see how they can have certain attributes, which are usually more referred to as fields and properties, which are variables inside the class. This word state here usually referred to the fact that once we have an object, like it says here, classes provide structure for objects. So like I mentioned, if we have a person, we can have a field that says the person's age. That will be an integer. But if I have a specific object that refers to a specific person, then this will contain a real number. Once we have a class instantiated with data, it can be referred to as the state of the class. This is more and more being used. It's not a classic term. It's more and more being used today. Also, classes have specific behaviors that means that they have certain methods that they can be executed. So a person can also execute certain actions according to what we want, like sit or stand. So here is a very rough scheme of class of an account. So a class must have a certain name, and here we have certain properties of the class. Those could be named properties and fields. These are two usually different, referring to two different parts on the class. We'll see the difference between them. The word attributes here is not very well describing, because in C# we have a different use for the word attribute, and we'll see them maybe in the future when we have to when we have to really use attributes. So the word attributes here, I don't completely like it. Why am I not showing it like this? But okay, let's say that these are identifiers of this class. They could be fields, they could be properties, and they could be of any kind. They could be integers, or they could be another class. Like here, this could probably be another class being used as a property of this account, or this amount, which is a double here in this case. And the class has certain methods. So if we have an account, we can suspend it, we can put a deposit, and that will require us to give certain sum, or we can withdraw. We'll have to specify certain sum. So that will be our structure. Once we have the class, we can create real objects with it and set them up with data, and that would be usually called an instance. And creation of objects with classes is called instantiation. We've seen that many times. We've seen how we create new arrays or integers, or other types that we've dealt, like strings. So once we have an instance of the object, it can have its own fields filled up for it and its own methods called. So they are completely living in their own world, and they are separate from each other, usually. So here we have the account, which is the class, and here we have specific accounts, which are instantiated objects, which contain different fillings for their properties. And this is what it would look like if the world was flat and square. So this is our model, this is our template, and these are actual accounts, and in every one of them we have different properties holding different data, and they are not relating to each other. So this is like our map of what the class will contain. Well, yeah, he is. He just doesn't know it yet. So, like I mentioned, in C#, everything is a class. And as we're going to go along using classes, we'll look more and more into the basics of what is object-oriented design and what is object-oriented programming, and what are the principles of this. But in many cases, a class uses there is this word called encapsulation, which is one of the. Sorry, guys. Thanks. So there's this word called encapsulation, which is used sometimes as one of the principles of object-oriented design, which is an important concept in which once we have a class, the class can expose. The class can expose the data that we want it to expose, but there is a lot of internal work sometimes which we don't want people to be aware of, and we don't want to be exposed to the outside. Guys, please. So for example, if I have a class of a car, or if I look, for example, at a real world car, then I'm the driver. That means that I'm someone who comes to use this class, let's say the car. I know what the class provides to me. It provides to me some data that I can read, for example, my speed or how much fuel I have, and I have my methods, for example, push the gas button, the gas pedal, and I can go forward, or I can input my own data. That means that I can change gears, for example. So in that case, this is my interaction with the car, but all the rest of it, what's going on in the engine at this point, or in my car's computer, or the fuel tank operations, or the pumps inside, or the tires, or all the springs and suspenders, I'm not really aware of all the data which is going on inside. So in some aspects, the classes are meant to be like black boxes as much as possible. They should expose whatever we need. So once I come to use a class, it's on a need-to-know basis. So the data inside is sometimes hidden from me, or some of the data is hidden from me, and it's managed in the back. So if, for example, I can feed someone's year of birth, I can calculate inside the class, for example, their age, and this process will be hidden from the user of the class. So in many times, the implementation of the classes is encapsulated. It's hiding whatever needs to be hidden and showing to the users of the class whatever they need to show, and they give the freedom to use only certain aspects of the class. So this is a part of the design when we're talking about object-oriented. These are the actual things a class can have in C#. So we have fields. Fields are just variables. So if my class has a variable of type integer, it's usually referred to as a field. It could be a public part of the class, that means exposed to the outer world, but in many cases it will not. We have properties, which are external properties, which are to be used by users of the class. They can be interacted with. We have methods, of course, so we can call the class methods. We'll talk about constructors briefly. A class can have its own inner classes, so you can define a hierarchy of classes inside a class. Sometimes it's needed. And of course, there's a lot more. It's really way too early to talk about events and indexers and operators, but these are also possible. So I can define operators for my class. I can define what happens when I use my class with a plus operator, so I can combine two strings, for example. Indexers are used, for example, in arrays or in dictionaries or in any way where I need to index my data. And events are used a lot in environments where we have when the class needs to respond to something. For example, if I click a button in Windows and the class needs to know that the button has been clicked. So the most important parts here are the fields and properties and methods. Constructors we'll see, and inner types, and the rest I think not today. So here are examples of classes that we've already met. The console class, which is a part of the system namespace. We'll see namespaces also today. We have the string, we have integer. These are all classes. The array that we've been using. Some of you have used the math class, and random, we'll see it today. There's not much to say about those. So here's an example of declaration of objects. We'll see a bit later about namespaces and how they refer to classes. They're just there to help us sort our classes in place. But for example, we have a class called datetime, which is very widely used in C#. And here's an instance. This is an object of this class, which will be called today. And here's another object of this class called Halloween. They are not initialized, but they are instantiated. So here's an example of an initialization and instantiation and initialization. I take my date time today and I put a value to it. The same way we did it with integers until now, or floats. So this is quite self-explanatory to you, right? I guess. Well, like I mentioned, most of what we're going to see is fields and properties. So they are all variables inside the class. They could be constants as well. So for example, we have the string.empty, which is, we have the string class, and it has a property here, which is a constant property called empty, and it always returns the same string, which is actually an empty string. Fields are usually just simple data objects. It could be an integer, it could be a string, it just returned from the class. When we're going to talk about properties, we'll see that they are slightly more complex sometimes. So, getting fields, of course, constant fields can only be read. We cannot override, so we cannot take string.empty and put something into it. Or we cannot take int32 and max value and put something into it. Yeah?
In this case, int32, is it object or class?
In this case, it is the class.
So we can use the class methods, just class methods, without making...
Yeah, good point. And good observation. Actually, if we look here at my string, and I've instantiated here a string called empty, and I initialize it with string.empty value, which I could have done with just empty quotes. But this string here is the name of the class. You can see that it's exactly similar to the string here. And the fact that I'm going to the field or property of the class, or calling a method of the class directly like this, means that this is a static property. We'll talk more about static attributes a little bit later today, but just in a word, static means that you are accessing the property directly on the class. That means that if I put, for example, a field in my class, like for example age, every person that I will instantiate will have different age values usually, and that's okay. But if I have a class for a string, I don't need every one of the strings classes to have every one of the string objects to have the empty field, because it will be similar to all of them. It's like a global kind of value that all the fields have similar, or all the integers that I have, for example this one, will have this field of max value. So this is what we call a static field, and once it's static, it's accessed by the class because it's global to all the instances in this case. So good observation. We are not referring to an object here, we're referring directly to the class, and this is a static property of the class called empty. And of course, that's the way to refer to properties and values and fields, putting a dot. Now, properties are much like fields, just that they have a little more powerful mechanism. We can control whether they could be retrieved, whether we can set them. So they have a set of what we call getter and setter. They're usually public, so they're usually accessible to the users of the class. And just like fields, they contain some kind of data. And we'll see a little more. It's better to see how they're structured, and we're going to see a little more about that in a live demo, and maybe demonstrate how they're constructed. But let's say for now that properties are accessible to the outside world usually, and we can have for them a getter and a setter. So that means we can control who can read them and who can write to them. So if we have a property which only has a get accessor, that means it can be only read. And if it has a get and set, it could be read and written. And if it has only set, it can only be set, and we cannot read its value from the outside. For example, string.length. Length is a property of a string. So every instance of our string, every string that we have will have a different length. But we cannot change this value. We cannot directly go to string length equals something. That will be...
does that mean that there is no set property, just that it's private?
Well, it's usually not private if it's accessible to you. But it could be public and read-only, and it could be a public property with only a getter without a setter.
So
you will usually get
a set. You can set it inside the class, right?
Yes, you would set it inside the class. For example, when I have a new string and I initialize it with a certain string, then at this point the length of the string will be calculated and stored for it. And when I access the length property, I can read it, but I cannot change it. Only the class itself inside its works can do it. This is so in this case it probably means that it's a property without a setter, without a public setter. It could have a private setter, but it's not a read-only property because it can be changed, but it cannot be changed from the outside. So that's quite a powerful mechanism also, which we didn't have in some other languages, and it's very flexible and good. So here is an example of accessing the properties of an object. Here we have again the date time, and we are initializing it with a certain date using the new operator here, which I think we've seen, but from now, once we start talking more and more about classes and instantiating objects, we'll see a lot more of this new operator. And one... Sorry? Yeah.
Why sometimes we just declare a variable date time without explicitly calling the constructor, and sometimes we call the constructor?
Because it can have an implicit constructor, and you could with the assign operator create your instance, for example in strings or in integers. But you can use the new operator, but if the class implements it, you don't have to. It's built for your convenience, but actually
because a lot of times I see like hash table variable name, and then you use the new command with the default method. Why? You can just write hash table and the variable.
That depends on the implementation of the specific class. Some classes have it and some don't. By default, if you build your own class, you'll have to call constructor to instantiate it. So back to the example. We have here, this is our variable from now on, and this is actually our object. And once this object is initialized, its properties are being set behind the scenes. So we are accessing here properties like day, month, and year, and we can read them. I think that, of course, we can also write to them. But this is the way we have an instance, dot, and the name of the property. That's how we access it from the outside. And of course, printing it out. And notice here we have a call to a method, is it leap year, which receives a certain year, which we're also printing out to the console, and again, this is the name of the class. This is not an instance, so this is a static method that we're calling, because there's no point in creating this method for each one of the instances, because this will always work the same way and return the same value for the year. Yeah, I like the illustrations. What do I do? Zdrave.
Merci.
Yes, I opened it twice. And I closed it twice. Okay. Come on. So let's have a look at it. Let's have a look at it again. What? Something is wrong. Yes, but still, you're right. You're right. Yeah, I thought, okay, in the previous times we were just opening a project in one of the solution projects and running it. We'll see if it adjusts on the next runs. But thanks for the tip. So here's our datetime object, which is called Christmas, and we can actually extend its properties from here or from the watch window, which we already know, and we can see these are public properties of the object. Better see it in the watch. So we can see all kinds of properties of this object. We can see some static members of the class, which are not relevant just to the current object. So in order to access those, I will have to use datetime dot and not Christmas dot. And we can see that some of the inner properties of this object are actually other objects that have their own properties. For example, time of the day, which has its own properties. That's an object in itself. So
these static members, we can call them just type with class, but we can call them with the instance.
I'm not sure you'll be able to access those, but let's see. For example, max value. No, it cannot be. The static member is only with the name of the class. And what I see here are only the static members. And static methods and static properties. If I look here, I'll also see the methods, but these are methods of relevant to this instance only. For example, add days, I will increment my date with a number of specific days. So this will change the values in this very instance. It's not global to the whole class. But if I look at a global static members, like compare, it will just take two objects and compare them. It doesn't need to be specific for an instance. So once we see those, we can see that we can read those properties and writing them to the console once they're put into these variables. Day of the year. Yeah, of course, the difference here is that we have variables here that we are putting into the string, into the right line, and here we have directly accessing the property and putting it into the right line. That's something that also we've been doing all along. And here we have a call to a method which we're putting right into the right line, which we've also been doing. And that's it. Here's the...
Actually, we have to define every property and every method and everything with some instance of known types.
Yes.
Known classes. How do known classes then are defined?
They are defined into the language, into the framework, and we'll talk a little bit about the basic framework of types in the .NET, but they are just there. Well, they are defined in their own environment. For example, integer, int, or string are defined in a namespace called system, and you must have certain components installed on your machine in order to use it. By the way, once we build a .NET application, or build a .NET DLL, or build any .NET component, these are usually referred to as assemblies, and that's a word that you're going to meet quite a lot if you work with .NET. So let's say that these are defined in specific assemblies which are used by the framework, which are built in, and they were defined there for you. And from then on, these are called primitive types, and all the types which are using them in the future are more complex types. So you build your own classes using them, or using more complex ones. You can put a date time inside your class, which is...
if you want to encapsulate, if you want to see how for example, the int class,
well,
how we can modify it and use it.
Yes, there is a way to look into the framework's classes. I'm not sure I have it here. Oh. Let's say no. Not sure it will work, but might worth a try. So if this thing works, I'll show you a tool which is quite useful by developers. The name of the tool is Reflector. Actually, when we build something in the .NET and we produce an assembly, the compilation of the file of our code is transformed into some kind of intermediate language which is read by the environment. And this language can be interpreted back into code, at least great parts of it. So unlike, for example, if we're talking about C++ DLLs that are built, we can really have a look into the code of other, let's say, closed C# classes, and this action of looking into them is called reflection. And there is a whole library of functions here called reflection, which allows you to go into classes, even if they're closed. You can read and write properties, even if they are completely hidden from you. You can access them, you can change them. That's quite hardcore hacking into someone's work, which is not all the time recommended, but it works. And this is a tool called Reflector, which is quite used by many .NET developers. It's a free tool. And I can look in here, for example, into the system DLL, which is part of the .NET Basic framework. And I should be able to see all the basis classes. So here, for example, is the system namespace. I don't see it. Yes, here it is. So I can see its methods, and parts of them I can also, here for example is an example of a decrypted code of the framework's int32 method directly. It can be read. So this code is coming from the most basic parts of the .NET framework, and you can look into it, and you can access it if it's, in many cases you can. Yes, everything comes from God, then it's zeros and ones.
What cannot be read? What cannot be read? Disassembled.
I'll tell you, I think I've seen every class that I needed to reflect. I've not yet encountered an example of something that was impossible to read. But this is quite an advanced tool, and it is useful, but not just yet.
You need to know what you're doing, because
you can't make no, you can't make changes. You can just look into them. You can build a program that will go into these properties that, let's say, they are hidden from you, and you can access them, like by force. But you cannot make changes in the code like that. Well, yeah. So let's talk about instance and static members. Oh, we already talked about that, so let's move on. So like I mentioned, fields and properties and methods can be specific for an instance. That means they're specific for an object, and every object will have them differently. That of course the methods will be the same, but once we run a method, it runs specifically for the instance that we are holding. Or they could be static. That means they're class-wide. They're all over all the classes, and that's why we all the object of the class, and that's why we access them directly by addressing the class itself. Yeah, for example, different dogs have different names. So that's specific for each one of the instances. But datetime.min value is something which is for all datetime objects. So we access it through the datetime class.
how do different things how we are declaring this process?
There's
how
a
we know if class, how when we are building the class?
there's a keyword called static. You say this.
With static we are declaring property which is accessible, and
Accessibility is not related here. Who can access this property is not relevant to this. But if I have in my class int age, that means that this age is specific for each instance of the class. But if I say static int age, this means that once this has a value, it's global. And by the way, in order to access this static data, I don't need to have an instance of a class. For example, if we look at this again, the day, since it's not a static member, I cannot access it at the class level like this. it needs to be on some instance. It has to have some kind of state, some kind of context. But like we saw, accessing static members, like this static method, I cannot access them on an instance. I have to access them globally like this. So the ones that are not the ones that are not static require an instance, and the ones that are static, they don't require an instance. By the way, I could have run this whole program without declaring all this, and I could still access date time is leap year without declaring an instance of the class. So it's quite global, and it does not require you to have instantiated object.
Can you access static variable outside the namespace?
Depends. Yes, basically you can, but that
just define it as static.
Static doesn't mean, again, static doesn't mean who can access the. We'll talk a lot more about who can access what, because we have public, we have protected, we have derived classes, we have our assemblies, which could be encapsulated as separate assemblies. We have different projects that can have different namespaces or different namespaces within our project. So whoever can access what depends on how you define the member, but it's not relevant to whether it's static or not. Once it's accessible to me somehow, whether it's public or maybe I have some access to the protected members of the class, once it's static, that means I don't need an instance, I just need to access the class as a whole. But once it's not static, I need a hard object at hand, something instantiated.
This one like to access the static, but for example, if we access the index in array class, we are accessing it with this.
That's a slightly different kind of accessibility. Yeah.
Yes, and if we want this kind of class, which has this kind of accessibility to index, for example, dots, they have different cells. And every cell has different property. And
you can define such classes. You can define your classes in such way, but they'll need to implement certain parts of the framework. They'll need to in this case, they'll need to implement a certain interface, and you'll need to implement certain functionality in your class for that. But it is possible. It's not relevant to these. Yeah. This is a specific implementation thing. Again, well, like we saw, to access the members, it's always with a dot, and if we have an instance member, we need an instance dot the member of, that means the property's name, and if we have a static one, we need to put the class name and then access the property name. And I think this is clear now, right? So here are examples that we've seen already. We have the length property of a string, that's an instance. And we have the console.readLine or WriteLine or all the functions of the consoles that you've been using. Since the console is the name of the class, it is global to the program, and we don't need an instance here. We are calling a static method actually. Well, methods are pretty much like, we already know how to write methods. And within classes, they are just defined. Actually, all the methods that you've written so far are defined in a class. And I think most of them, or all of them, are static methods, because we were building them in a way that they need to be accessible to a static method. So accessing the methods in a class are similar to accessing properties. We have to have, if it's like this, a static method like readLine or WriteLine, we set the name of the class and the name of the method. And if it's a non-static method will just call it with a object. So the syntax is, like I mentioned, we have an object, dot, method name, and then the parenthesis. So if this was console, if this was a static method, console dot, write line, and then the parameters like we're providing every time. Here's an example of calling methods of string. We are instantiating here a string using the new operator, and this will produce us a string which has 5 times the letter A. And here we're instantiating another string. We're taking the first string and we're calling a member method called toUpper, which will take the string, put it all into uppercase, and return the value. We'll assign it to the second string, and this is the result when we're printing them out. And some methods of datetime. Again, we're putting a datetime. This datetime class has a static property called now, which always returns the time now, and we're putting the value into a variable here. Every time we call datetime now, we're trying to read datetime now, it will return the time now, but now we're storing it, so this thing will not change anymore. It will store the time at the time of the assignment, and we're calling a method of the instance itself called add hours, which will add 8 hours to the time, and we're taking this value and putting it into another datetime object called later. And when we print them out, we'll see the time when this assignment was performed, and then the time from this assignment and 8 hours later. Question? Yeah.
I understand how we are defining static methods and static properties. How we are defining in class these other for the instance methods and properties. Is there something special?
No, that's the default. If you don't specify static, it's an instance property or an instance related method.
So now and later the same object? Or just instantiate a different object?
No, we are instantiating a different object called later, and we are putting into it a value which is returned by a function here. So now.addHours will return a new instance. It's not a new instance, it will return an inline instance here of a datetime object, which is this time plus 8 hours.
So it creates a new object and then...
Yes.
Alright.
It returns an instance of an object. Add_hours returns an instance.
If you do just now.addHours, you keep nothing, right?
Yeah, it will run the code in the method, but the return value will go nowhere. I really don't know what's with those pictures. So the same demo, not this one. Something has happened here. Why do I have to set it every time? Okay, so here we are instantiating a string. By the way, just to make sure. So here we're instantiating a string, and once instantiated, it contains 5 times the letter A. And once we call the method toUpper, we'll get returned an uppercase string, and we'll take this value returned by this method and put it into another object. Now the date time, we are putting the value of now into a variable called now. And now we call the method add hours, take the value returned by this method and put it into a new instance. So this one will be 7:15 and this will be 3:15. More questions? Let me go here. So static methods, as you can understand, we're talking again and again on the same concepts. Are again just like static members and just like methods, they return a value or not return a value. They have their parameters, and instead of using them with a specific object, we're using them with a class name dot call the method name and parameters, just like this. Okay.
What is the difference accessing some property in the method inside the class and accessing a property outside the class? Because methods, they can access some properties inside the class. Sometimes they are already defined, sometimes not. But if we are creating new instance, for example, and inside the class we have a method which is using some variable or some property which needs to be declared for them, and we are searching for this method that is variable.
No, I think it will not let you. Static methods can access only static, whatever is static, because the static does not, it relies only on static data. It cannot rely on object-related data.
So all variables, we are defining them as static?
Yeah, if you want an access by static, you need to define whatever you want to access as static. And yes.
Where we are setting some value for this variable?
Yes, it will have to be set. Or you can, yeah, you can define it without setting it to anything, and it will have the default value. It could be also, someone could also update it and then call your method. It's also a possibility. It can be updated from the user of the class and then returned by the method. It's possible. We'll see more about accessibility. I see that this, who can access what in a class, is an interesting question here, and we'll see it in great details. So what do we see here? We see a call to a static method of the math class, which calculates the power. So we have radius in the power of 2. That's how we calculate the area of a circle. And this pi is actually a field, but it's probably constant. It's not changeable. It's not updatable. It's just there, and it's a constant number. Again, this round method calls are also rounding numbers is also something which is not relevant to a specific instance, and it's always performing the same action. So that's another static method. This I really don't know. Okay, so we're actually creating an instance of double. So we have here a double. Here we have the pi, which we can see its value. Here we can see, if we look in the debugger, we can see, since we're looking at the class, we can see the static members of it. So these are two static members of math, which are always there and never changing. And we have here a static method call. Here we have another double, and here we're calling two more static members, round, which are rounding the number. I mean, these actions are just mathematical actions which are never changing, so they're not relevant to specific value of a specific instance. So they will always perform the same action, always return the same value, and that's it. More questions? Not this. Yeah, the answer to this is yes and no. There is a demo, but it's not a live demo. It's in the slides. But we can paste it into a real project and see it in the works, or we can just define our own class to see how it looks. I was planning to. Yeah, I was planning to show this demo class, but maybe it's a bit too big, and we'll just build our own class and see how it's declared. Constructors, another important part of class. By the way, just to see where we are. What's the level of tiredness and coffee consumption needs? We can go a little more slides and then take a break and then continue and then go to the exercises. But I don't want to miss the cafeteria time. So constructors are another one of the important building blocks of classes. Constructors is a method which is run when a class is instantiated, and it can do all kinds of things. Actually, we saw properties of classes. We saw some static properties and we saw some instance properties, and these properties can have code behind them. They can contain or they can return a certain value, but they can have all kinds of code inside them, which processes data before it returns it to you, or after you set some data, it can process it. So constructor is a method. Many times it's instantiating the class. We're not thinking about it, but there is code behind it which is processing the data that you're feeding your class. They must have the same name of the class, and they do not return a value. A class can have a few constructors with different structures, with different parameters that instantiate it in a different way. And they can be also related to each other. I guess we'll see a lot of constructors. Constructors are invoked by the new operator. So every time you see this new and this string, for example, this is actually a method call. So this will call the constructor of the string class, which receives one parameter of type string. And this will call a different constructor of the string class, which returns an instance, which receives one character and an integer. And this constructor that we've seen in the datetime class received 3 different integers, or this one that receives 6 different integers. So these are different. Once we say new and the name of the class, we have to call the constructor, and this will return us the instance after the constructor has run and the data has been processed. For example, if we talk about the datetime, we are feeding the constructor function, the constructor method, with those 3 integers. It will take them and it will populate the class properties accordingly. And then when we have our instance, it will have this value, these values set in the class. So this is the work. This is usually the work of the constructor. It can do a lot more. It can do pretty much whatever you want. But the basic idea of the constructor is to initialize our class and to take the data and put it in place. Yeah.
Are those constructors predefined methods?
Yes.
Or same?
Yes. Yeah.
Different.
They are predefined in the class. What do you mean?
It's a specific construct that is defined in a very specific way.
It is a method. It's a method which has the same name of the
Yes.
class. They could be, as you can see, different methods with different parameters, so they can overload each other. We saw some overloading when we talked about methods. So you can have a few overloads of the constructor, and whatever they do inside is up to them. But somebody wrote this method. Here's another way to initialize an integer, not just with directly, but yeah, we mentioned that. The parameterless constructor, which has no parameters, is usually referred to as the default constructor. Yeah, again, examples. So here we are using another class called random, which is another part of the framework, which generates random numbers. We'll see some uses of it later. Yeah. So here we are instantiating it with a constructor. I think this number is wrong, by the way. And I think something is missing in this slide. In any case, this random class has has two constructors. One of them is a default constructor without any parameters, and one of them receives an integer value, and it will generate. Once you call the next method, it will generate and return random numbers that you can use in your code. So here we have one instance, and here we have another instance, and I think that this number cannot be returned by this.
Is this an integer parameter or not?
Yeah, I think it's an integer parameter.
So,
Or either it's integer or long. I think, let's see it right now, and then we'll see exactly how it's built. Okay, that's the missing part on the slide. So here we have three different objects of type random. That's a class. One of them is called with the empty default constructor, and the two of those are called with the constructor that receives integer and returns the random, of course, because it's the constructor, but the next returns also an integer. So if we do not specify a parameter here, it will call the default constructor, and I think it will try to generate the number that we're sending into the random function, into the random constructor. The number that we're sending to the constructor that receives the parameter is called the seed, and that gives you the maximum value of the number to generate.
no, seed is
From 0?
something different. Seed is used in determining how the sequence plays out, because it's a pseudo-random generator, not a true random generator.
Yeah, I think you're right. Sorry, I think the number here will give you the range. So, yeah, you're right. The seed, I think that the default seed is relating to the system clock, and
Wow.
yeah. Well, in any case, once you do not specify parameter, it will call the default constructor with a seed, which will be taken by the method itself. as far as I know, relative to the current system time.
That's the usual.
Hmm?
That's the usual.
Yeah. And here we have two more calls to the constructors with integers that will return two different objects. And here we have, on each one of them, we're calling the next method, which is an instance method, which is also overloads with three different options. All right. So here's the first object. Yeah, it doesn't have any members. It has only methods and static members of the class, which are also not existing.
What?
Yeah. If we look at the class from here, we'll see it doesn't have any public member variables, doesn't have any properties that we can access. That means that we can access only methods in this case. We can see that in the watch. So there are no members here displaying, and when we put the dot, we'll see that it has only methods to be called. These are again the static members of the class, which are also non-existing. And on each one of them we have non-public members that you can see, but you cannot access them. They can be read. You can, once you have an instance of... No, they're not constants. They're just not accessible to you. You cannot read them from the program, and you cannot write to them. You can see them when you are debugging, but they are not supposed to be, you're not supposed to be touching them. Private or protected, yeah. In your class you can define whichever you need, but in this specific class called random, they are private. They are not accessible to you. And that's again another different object constructed, and another one, and we have the three random numbers generated. Okay, more examples of constructors that we've just seen in the previous slides. So as we mentioned, constructors, the function itself, when you define a constructor method, it doesn't return a value. It's a void method, but actually when you call it with a new keyword, you are returning a value which is an instance of your class. In this case, date time. And this can be assigned to an object here, and they can be overloaded constructors with different numbers of parameters and zero numbers as well. Really? Well, really not much to show here that we haven't seen. So we are instantiating datetime object with a one constructor and printing it out, and instantiating another. Here we are first defining the object, and then we are assigning a value to it, and here we are putting it and declaring it and initializing it at the same time. So I guess this is also not new to any of you. And the printout is this. And that's it for that. Enumerations. Also, some kind of declarative data that you can have in your programs, which are this is quite a short thing to see, and maybe after that we'll take a short break and then continue. So enumerations are in languages like C# are very equivalent to numeral values. In C# it's a little bit more separated, although they can be converted to and from their numeral values. Many times when you have a program where you need to specify values like a color, or a month, or a day of the week, you can specify it with a collection like this, which you define different values to it. So in this case, we use the keyword enum, and we're defining an enumeration. These are usually equivalent. They're actually stored in memory as different numbers, as different integers, but they can be accessed like this. For example, color.red, or you can have a method that receives a type color in one of its parameters, and it could be one of these values. So instead of just putting numbers or strings or something which is completely fluid, you can use enumerations, and you can set specific values to be used in your program, and that will make it much more stronger, developer friendly, stronger typed. So that means that if a method should receive, for example, a number that represents a color, it's one thing, and programmers can make mistakes, even though programmers don't make mistakes. But if I set a parameter of type color which relates to this enumeration, they can specify only one of these values here, and otherwise the build will fail. So this gives a little more concrete way of just defining predefined values of something, and that's quite useful. Maybe we'll see also an example of that, because there is no live demo of that.
Can the values be of different types? I mean, one integer, one string?
No, I think not. They're not relevant to really store data. They are just giving to have certain values that are represented by these members. They're not really to store some kind of data for you. And that was that. So
another question: is it possible that one of the members is an instance of another object? For example, we can have an enumeration of specific dates, like Halloween, Christmas, or so on. And is it possible to, in that manner, mix the types of the members?
I think not. I think not.
I think that remember there are not some type of numbers, like specific class or something.
They can be converted to and from their numeral value, but they are not. This is not such a fluent. You have to cast it, and you have to or call a parse method in order to do that. These are just. This is just a small, simple thing that allows you to give predefined values that you know that they are more concrete to be used in your program. For example, height or age can be any number, but
or you have some settings or something.
Yes.
In your program that you would like to refer to with their names, not their obscure numbers.
Yes, or for example, hair color can be a predefined set of possible.
This new code has a lot of static, not public methods and actions.
No, there is an Enum class which has some kind of which has a few methods. For example, in order to parse if you're given a value and you want to parse it to see which value of the enumeration it relates to. So there are some methods here which are which can be used with Enum, but in general, what you see here is what you get in 99% of the cases. More? So, before we continue with the rest of the stuff, let's take a break. So, we just have a few more slides to go through, and then there's a short demonstration of a class structure, and since it's not a live demo, I'm going to make it probably into a live demo and show a little bit on the building of a real class. So structures. Structures are, just like I said, they are similar to classes. In C++, structs and class are exactly the same thing. Their only difference is the default accessibility to them. Where in class the default accessibility is public, and in struct the default accessibility is private. Actually, it's the other way around. Yeah, structures are the public, and classes are usually by default more closed. So structs, when we are talking about structs in C#, we're talking usually about classes that store only data without any functions. And they have the fields and properties, and they can have methods, but it's not recommended. There is a distinction between value type and reference type, and I think I've mentioned it a few times, but we're going to talk a little bit more about that at the end of this presentation, when we're going to talk about the the built-in types. What? Okay. So we have a distinction between value types that are storing values, and there are. I'm going to stop this thing. So the distinction between reference types and value types is a little more deep, and the way that they are handled by the framework, and the way their memory is handled by the framework, and the way that when you access one of them, if reference types are usually accessed by their reference, that means that when you are changing one value, when you are assigning a value to another variable and you are changing a value, you are changing it by the reference. And in value types, this thing is different. For example, when you assign an integer from one variable to another, making a change to that, you're not changing the first integer. So as opposed to classes, all the classes that you're going to define are reference types, and structures are actually handled as value types by the framework, and that's a big difference between their memory usage and the way that they're referenced by the framework and by our programs. An example, datetime is a structure, and it's built to contain data. There are some static methods to it, but it's not built to be some kind of functional class with methods. It's built to store a data of date and a time. And
like big integer, for example. Like big integer.
Yeah, like big integer. Actually, it does base maybe on. I'm not sure it's basing itself by.
Big integer is a structure.
Yeah, those are all, yes, those are all structs in a way. They are value types.
So how does Enum fit into this?
Hmm?
How does Enum fit into this?
How does? Enum.
Yes, Enum.
I'm not sure about its implementation in the background.
Well, strange.
Yes, it's a collection, I guess, of integers. That's my guess, but
In the memory, it is aligned as an integer.
hmm?
In the memory.
The enumeration.
Yes.
Yes. Yes, and an enumerated value is equivalent to an integer, and you can cast between them. But the enumeration itself, the enum itself, I'm not sure about its
You can
implementation.
refer to the Enum, like I mean, like class.
You can.
You can refer statically,
Yeah.
like.
Yes, there is a class enum with
I mean,
static
no,
methods.
I mean, you can Enum, you can refer sort of like you can refer to static classes, and then you can also refer sort of like instance, because you can create.
Yes,
an
you can.
Enum,
Yes.
Sort of an instance of an Enum, but I never
Mhm.
really
Yes.
understood all that well.
I'm not sure about the internal implementation of it, really. Namespaces is another another concept that we've been using all along. Namespaces are just there to organize your code. They are just names that are given, that are wrapping your classes, so that you can have, for example, we have the namespace system. So all the classes which are defined under the namespace system are global classes which relate to the system. For example, system, all the primitive types like system int32 or system string or system data in this case, which is it's actually another namespace. So it's good. Every time you create a class, by default it will be wrapped in a namespace, and it's not necessary to really wrap all your classes in namespaces, but it is good practice to keep a namespace on your classes. And when you build a project with folders and you put your classes into some kind of classification, for example, all the classes relevant to security, then you will have, by default, if you create a folder in your project called security, all the classes that you put in there will be nested in a namespace called security. And anyone who wants to access your class will also have to use the namespace one way or another. So this will give some kind of classification to your classes, and not just to classes, to all the data types that you're using, if it's enums or structs. So it's not necessary, but it is good practice, and it's recommended to always use them. So as you can see, they can contain definitions of the class, structures, interfaces, all the types that you're going to use, and they are wrapping also the system, the basic framework classes like the system one. And if you have classes in the system which are relevant to data, it will be under system.data, which is another namespace. So you can create namespaces which are also with sub-namespaces. If you want to refer to a class, you must do it with its full namespace. So you have to specify the namespace of the class and then the class name. So for example, if you want to refer to string, you have to refer to system.string. Actually, in string and int, there are some shorthand names to them. But if you're referring to an array, for example, you have to use system.array. That's the full name of the class with the namespace coming first and the name of the class coming second. If you want to avoid using that, you can put using directive, and here you can put namespaces that you're going to use in your code, in your current file, and that way you will not have to give the full name, you can give just the name of the class. So if you put using namespace system, like here, you can use all the classes which are defined in system directly, for example, date time. But you can also use the full name, like system.datetime, if you want. This just gives you some kind of shortcut. Okay, this is an example of a class that is going to generate some random character of strings. So we're starting here with a loop that is going to generate 6 numbers. There's a loop running from 1 to 6. We have here an instance of the random class that we've seen earlier, which is initialized with a constructor, with the default empty constructor. That means it's taking its seed in itself. We are not supplying it. And we are calling the instance method next, which gets one variable here, 49. That means that it's going to return a random number between 0 and 48, I think. And then we're adding 1 to it, so we're shifting it from 1 to 49. So this loop will create 6 different numbers randomly, and every time print them to the screen. So the task here is to generate a random password between 8 and 15 characters. And we have a few rules here. So the idea is start with an empty password, start with an empty string. Then we're going to place 2 random capital letters at random positions. Then we're going to place 2 random small letters at random positions. Then we're going to place 1 random digit in a random position. And then we're going to place a special character in a random position. And then we're going to construct our string like this. And since our rule was to create a password which is between 8 and 15, we've now constructed the 8 characters length of a string, and we're going to generate now random numbers and append them. Just append random characters to the rest of the password. Okay, so let's look at the class itself, because I think that's the more interesting. We have some functionality in it, but so this is our class. We're calling it random password generator, and that's how we're declaring a class in our program. So everything in a class, everything in here is of course between curly braces, just like every other code blocks in C#. And we are defining member variables to this class like this. In this case, we have constant strings here, which contains, for example, all the capital letters, all the lowercase letters, all the digits, all the special characters that we can use in the password. And we also have one constant string that takes all the characters together. We also have a random number here, which is static to the class. All these fields are private. That means they cannot be accessed outside the class. So this keyword that you're going to encounter much more means that this string can be accessed only within the class itself. That means it can be accessed only by other members of the class. It can be accessed only by fields, other fields of the class, or by methods of the class, but it cannot be accessed outside. Okay. So actually we have here other methods. We better look at those methods first. So we have private methods. Again, if we look at the class, these are all private fields, and they're also constants, so they cannot be changed, and they contain those strings in the class built. In other words, they are just like they were static in a way, because they are always there in the class and they are not changeable. And then our private random here is also static in the class. And now we have a few static methods that we're defining. For example, a method to insert a character at a random position, which will take our currently built password and a character, and it will get a random number and insert a character at a random space. I mean, this example uses string builder, which we haven't discussed much, but this is a class which allows interaction with strings, building strings, and manipulating strings in a way which is better than using the string directly. So this example, I would like to use it. I think it will be better to be shown. So let's try to copy it, because I think if we run it into a live demo, it will be better. So I'm going to add here another project to the solution. I'm going to call it password generator. Ah, not this one. Yeah.
I didn't choose console application.
So as you can see, the new project, let's set it as
You can set that in the solution properties, and you can set that the currently selected project is the startup project.
in the solution properties.
The solution, yes, properties.
Maybe that's the difference. Oh, yes.
It's by default switched off.
Yeah.
You know that you just simple that.
No, I didn't remember the setting.
You never?
I am sure I've seen it, but I usually go from here, because usually when I build a solution, there is one startup project in it, and you just set it and that's it. You don't start changing. But in this case, when we have different console applications in one solution, and then you have to run each time a different one, is not the usual case.
Because we are running like that for now, just
Yeah. Yeah, that's okay. But I usually don't use this property. So here's our project, and as you can see, this file, which was added to the project, program.cs, which is always added, has a namespace which is given, and it corresponds to the project name. And then we have our class with a static method of main, which is always there to be called when the console application starts.
Actually, I found out that it's really tough to change the namespace. I mean, you have to change the namespace, then change go to program, change the folder name.
In
No,
the
I think
properties of the project there was a default namespace.
Yeah, that's different. But if I change the namespace here, it still builds and it still runs.
Yes, but then after that, when you go to again, it says like the folder where is your namespace is different than the, because it's building in Windows in your solution there, but it's building some folders.
Yeah, but that I think doesn't matter to the namespace. I can have multiple namespaces in my project. I don't think it's a problem. If I build it, it's okay. And if I close,
And then it's not changing the folder.
yeah, okay, the folder stays, but it also corresponds with the name of the project. That's, yeah, if you want to change everything, you want to change the name of the project, the namespace, and the folders, then you have to do some work. But basically in your program you can set namespaces to whatever you want. It doesn't relate to any problems.
I mean, it's hard to change the project name, not the namespace name. The folder remains with the old name.
Yes, it's
Yeah.
That's a problem.
Yeah, that would take a little more work, you're right.
I found out to do it and I checked in Google, it's coming from
Mm-hmm.
it's fixes. Then it became some problems and then to Telerik to
Yeah, if we need to change the namespace,
yes.
I'll call you. So let's add a class here. I can define other classes in the same file, but just for the sake of demonstration, we'll quickly add a new class. So I'll add a class to my project. I can add a new item, which can be many things. One of them is a class, and since classes are so commonly added to projects, there is a shorthand here which is add class directly. Just give it a name, for example, generator. And I've added a new file to the project. It resides in the same namespace as the main program in this case, because they are in the same folder next to each other. And this class has a name. And if I want to use this class publicly, I would usually make it a public class. And now this class is accessible from my program. I can already go to my program and I can see that this is my class passkeyword generator console.generator. And I can access it. I can instantiate, even though there is no default constructor. I can call static members, even though I don't have static members, only the ones which are inherited from the basic object. And in here I can start defining my properties, my fields, my methods. So I'm not sure we can really try to use this example, but let's take the code from here. And place it here to see if it really works.
I have a question. Don't we have to make the capital letters, small letters, and so on variables static? So when we call so we can call a method from our class without initializing an object of the class.
Yeah, I think they might be. Oh, they're all privates.
They're constants, like
Yeah, but since they are constants,
Still access.
you should be able to access them. So they are
constants
accessible.
means they're also static.
Yes. So we've just defined those as constant strings, which are, and we have another public static variable here that can be accessed without a state. Here it is. I can, since it's defined and initialized, I can immediately call its. So here I'm accessing my member variable, and here I'm accessing the methods of the random class, which is the class of this instance of this field of my class. Okay, let's take the other parts. I'm really not sure this code will work, but let's take it. So here we have defined two methods in our class. One of them will generate a random character from a collection of characters. So we're giving this method a string. We're generating a random index within the boundaries of the string according to the length of the string, and then we're extracting a character at this random index, and then we're returning it. And this is another method which uses the random functionality of this random variable inside our class. We have our string builder, which builds our password. Just a moment. And again, we're using our random variable in order to get a random position within our string, and then we are inserting at this position the character into the string, and this insert is a method of string builder class which we have here. So we have an instance of this string builder, and we can call insert, which will take a character and put it into the string. It's, by the way, if you're using strings and manipulating them a lot, it's much more economical to use string builder rather than a regular string, but that's just a short. Now this method, which is actually built into the main, we don't really have to call it main. Yeah, because it continues on the next slide, but I'm going to have to take it in 2 times. No. Actually, I'm not going to have a main in my class. The fact that this function is... Yes. We'll make it public, and we'll call it something like print password, print random password. So this method will use the other 2 methods, and so I can see that I can call the other methods of the class from within this method. So for example, I need to generate 2 capital letters and put them inside. So I'm taking out a character from the capital letters string, which is a constant string with all the capital letters. We've seen how this works with the random to extract a specific character. We're taking it, and then we're inserting it at a random position to our password string. And we're doing it twice. And then we're doing the same thing with the small letters, and we're doing that one twice as well.
So generate what?
Hmm?
By the way, inserting it's not replacing the character. It's just inserting one character before or after the command. I got your point with the actual password, which is it's string builder.
It's a string builder.
It's kind of this with
It's kind of a class that helps manipulate strings. When you have to concat strings, when you have to insert characters into a string. If you do that with a regular string, every time you manipulate strings with a regular string, you are creating a new instance of your string. Every time you do, for example, string plus string, and you're copying them to a new string, you're creating instance of a new string in that case.
I see that, but I can understand what's going on. We are inserting, for example, in position 3, some character.
Yes.
For example, H. What's going on in position 1, 2, 4?
They
5?
remain.
They can be spaces because it's character.
Yeah, the string builder will do its work behind the scenes, and then it will be able to get you whatever you've built. I mean, whatever characters you've placed in it, it will return to you in the end.
It will return a string without all these empty spaces,
Yes.
which are not in the string.
So using these other methods, we're just generating and placing our characters into the password. Let's see it actually, and then we can look also into the string builder. Let's put a breakpoint right here. No, just actually here, at the entry point of our class method, and that's called this method. So we're going to, since it's a static method, I'll use my generator class, and I'm calling the method like this. And let's run.
When you're debugging, it's not.
Because I put the breakpoint here. Yeah. If I stop it, I can put the breakpoint here. And then I'll stop here.
When you go in,
When I go in, I go to where I have to be. Yes. Let's try to follow our string builder in action. So, we have the loop. We don't really need to go much deeper into that. First, now we're calling the generate character method of our own class, so we can also step into that. And we are now in the generate character. We have the available, which are all the uppercase characters. We're taking a random number, which is up to 26, which is the length of the string. We took an index of 23. We'll get the character of this position, which is, in this case, 88. Sorry, that's the character value. That's not the position. So that's X. That's our character. Here it is. And now we are inserting it at a random position. We're calling the method, the other method of our class, and if we step into that, here we are. This is our string builder, and these are our character. It will go into the string builder. So string builder is a class in itself, so we can see all kinds of properties of the builder while it's still at work. The random position is, in this case, 0. And yeah, actually the random position is here calculated by the current length of the string, so it will not put it in place. If you have a string which has not been initialized yet, it will not put it in place number 20. And so we're done with this step. And this thing will run again and again. And we can see every time that our password string is being constructed randomly in every iteration. And now we have another 4 characters to add. This function is done running. It is printed to the console, and that's it. A few things that I've noticed here. If we look at them functions, we can see, for example, that this function requires a string builder to be sent to it. But since we have already a string builder in the class, and this is the actual object that we're going to send every time, we don't need it to be sent as a parameter here. Instead, we can use our own. Do we have it? Oh, sorry, no, the string builder is a part of this method, so it has to be transferred to the other method. The only thing which is not inside the method is our random number generator and those strings. But does this give a little more structure of what we've talked about? We're going to see much more classes from now on, from the inside and from the outside. And it was just important for me to really show it live, because in the slides I don't.
Can we call just one of the methods, which is some random chart? There was one method. Can we try?
Yeah, we can.
Assign in program to some chart? No.
You mean, for example, this method that returns a character?
Yes.
Yes, we can. We can call it generate. Why? I have to send a string. So if I send any string that I want, and here it is. It's generated a random character from the string that I've provided. I can also, for example, take, instead of using my string, I can use one of the other strings. For example, capital letters. So in this case, my character every time will get a random capital letter. So that's okay, but when I design my class here like this, I have to start thinking about what I want to expose to the outer world. For example, insert at random position, let's say, is not something that maybe depends on the functionality of this class. But if this class wants only to generate a random password, then I don't want people to start calling this method just for their own use, or this is something internal for my own implementation. So in this case, I will not expose this function. I'll maybe keep it private.
Also, you want to get different options for the length of this generator. So you want to.
Yeah, I can add other, like create me a password. I can add, for example, a parameter here that will tell me what the length of the password that I need to give. Or I can set it as a property of my class and then use it here. I can put it in a constructor. For example, I can. Yes.
It's not very concrete, but can we design a new ML directly from this solution?
Ooh, I'm not sure. I think there is a tool for that. There's a class diagram. Yeah, this is it. It is a UML diagram of the classes. Yeah, it's useful for documentation. If I want this, well, this class is mostly with static members, but I could, if I want, provide a constructor, just for the sake of showing. So once I have a member function which is void and with the same name of the class, I've just defined the constructor, and here I can do whatever I want. So that will be the code that will be called every time I instantiate this class. For example, once I have a constructor, I can instantiate and let's put a breakpoint in the constructor. No, you don't specify a void. That was my mistake. Because it doesn't really return a value. It returns a value of the instance of this class. So once I call the constructor with a new operator like this, I'm getting thrown into the constructor method, which is now being executed just like any other method. Usually it would be for setting data into my class members, and once it's done running, the instance is created and we can assign it like this, and now I have an instance of my class with all the properties and fields and methods, even though this class has only static members, so there'll be not much to see, but I can see them here under static members. Okay, that's what I wanted to show about this. Any more questions about this? Yeah, about the get and set that were specified. Let's close the other windows. Yes. So, for example, let's leave let's leave all those static ones and create one which is not static. For example, call it Now once I define it like this is an integer which is publicly accessible from my class, but I can define it as a property if I open the curly braces, and inside here I specify get and set. So this means that this variable can be accessed from the outside, it can be set by the outside program, and it can be retrieved by the outside program. The other way around. I can get it and then I can set a value for it. And for example, I can set it in the constructor. For example, I can put here a variable. And in the constructor, if I receive a value here, I will set the current value to the one that is given in the parameters, like this. Another important thing which we haven't mentioned, whenever you're accessing an instance of your class and you're accessing a variable or a parameter or a method inside your class, once you have an instance, we can use a keyword called this. This is actually the current instance that we are working on. So if I have called the constructor and I've generated an instance of the generator class, inside the class I can refer to this instance that I've just created with the keyword this. And it is good practice whenever you are accessing such properties or methods to use the word this dot, so that it will be clear that you're accessing a parameter from your own class.
We don't define it, it will be 0.
Yeah, it will be the default as 0.
It makes it explicit, but is it really necessary for something?
No,
We can make it.
you don't need it. I can avoid it, but it is good practice to use it like this, so that it's clear what we're accessing.
And now we can make this constructor
Overload.
override.
Yeah, for example, I can set another constructor without parameters.
And then set some default.
Mm-hmm. So we're really getting a bit into this. So for example, I can set it here to be something else. By default, that will be the default now. Once a class is generated, once I have an instance, this will be it. This will be the value here.
And now if we replace the 8 where it's in the main method, it was main, now it's not.
Yeah.
We replace 8 with this
This won't work because this is an instance member and the other is a static method, and I think they cannot refer to each other. We'll have to make a few changes here in the structure. But that's what I wanted to show. And one last thing about such constructors is the fact that constructors can refer to each other. So I have here the empty constructor, the default one, and another constructor with a length. And if I don't specify anything here, I can leave this blank, and this constructor can call the other constructor. There is a way to do that. So if I don't specify anything, this constructor, if it's called, it will call the other constructor, and it will pass the value of 5 to it. So it will call this constructor as well. So if there is any code here, it will also be executed here.
If there are more overruled, then it will take the
Yeah, but let's not go into that. So about the getter and the setter, if I don't have set option, then I immediately get an error here because I cannot set a value to this property. Or I can say this is only private set. It means only I can set it in here, but from the outside it's not legal to set value here. And last thing, I can put some code here. I can put, as if it's a method, whenever somebody sets some value, I can call some code here, and this will have to return some kind of value. That's why there's an error here. It has to return something. And set, I can just write whatever I want inside here. So whenever someone sets a value here, I can actually run code as if it's a method.
For example, we can say mods.app, so we can get the absolute value of what the user has sent us to our constructor.
Mm-hmm. Not sure I followed this. What do you mean?
In the setter, we can, for example, say mod.app, so we can take the absolute value if we only work with absolute values.
Mm-hmm. Yeah, it's true. We can change the value that the user has sent, and we can run code here as if it's a method. It is a method in a way.
Yes, this is what they call syntactic sugar.
What's that?
What?
What do you mean?
Well, just providing something, some feature in the language that is very common that in a shorter form or something like that.
Yeah.
And they usually call it syntactic sugaring.
Okay. Usually it would be like this. We would have a private field and we would have a public property, and they would be referring to each other. So when I'm returning the value of the private one, and when I'm setting the value of the private one. And here I can run all kinds of code. For example, I want it to be, like you said, I want always to have an absolute value.
You can have some sort of verification of the input value.
Yes, you can throw an exception. So this is it. I think we're going a bit too far into that, and we don't have much time left, actually. So just a few words, last words about the common type system in the .NET framework. So we already know some of the primitive types that we've been using all the time, like int, float, long, string, datetime. All those types are defined, predefined into the framework. We've even looked into that in more detail today with the reflector. And so all these are built in, and we know them, we've seen some of them. They are also following, of course, the object-oriented design, so many of them are classes which implement all the things that we've seen now and much more. We haven't discussed inheritance yet, but all these types have a basic type called object, which they all implement inheritance from. Each of the languages of the .NET framework, supported by the .NET framework, implement them by slightly different names, but there is a name which is defined in the type system itself, which is the absolute name of the class. So in C# we can use this word for int, but actually the name of the class is really system.int32. And in Visual Basic it will be a bit different, but it still refers to exactly the same class. And actually when you're building applications with .NET, it doesn't matter if you're doing it with C# or VB or Python or JScript.NET. They're all actually generating the same code that you can look through with the reflector, and they will use the same types and the same common types, which are the basic primitive types which are defined in the system, in the system of the framework. And there is always the system.object, which is the parent of all these classes and all the classes you will ever create. We mentioned, again, value type and reference types and the way that they behave, and they are passed by referring a piece of memory. So when we make a change, for example, in an array, we'll actually make a change to all the arrays that have been initialized to this value. And when we're making a change to a string, we're not really changing all the other strings which have been assigned to that string. So these are two different memory management of the variables that you're defining. I think I also mentioned the stack and the heap. So whenever we have a value type, it's in the execution stack. We've seen the stack tracer, we've seen methods when they're executed, we've seen the stack of memory where they are stored. And once we're out of the function, once we're out of the method, this stack is being destructed, and these types, these objects disappear from memory. Whenever you are putting a reference type, for example, your own class, when you are instantiating a class, it will be put in a different type of memory, which is called the managed heap, and that will be stored there as long as it's needed. there is a special process which is running in the background, which is usually called the garbage collector, which goes over this heap and finds out which of the objects are no longer in use and frees them from memory. They are not removed from memory whenever you are exiting a piece of code necessarily. So the memory management of value types and reference types is different. So most of the primitive types are value types like integers, floats, also strings. Strings are reference types actually. Booleans, structures, as we've mentioned today, are as different from classes, which are all reference types. All the classes that you're going to create are reference types. Strings and arrays and all the more complex types in the language which are actually usually classes of some kind. They are reference types. And since all of them, like I mentioned, are children of the type called object, which system.object, or in C# it's a lowercase object, they can be also assigned to this object. This is the most basic type which all the types in the language can be assigned to. For example, I have a string here, and I can assign it to a variable of type string, but then I can take the string and I can assign it to a variable of type object, and that will work. What we see here is the implementation of the toString, which is a common implementation which is put in the system object, which is the base class of all the other classes. So that's how we can take pretty much any of the classes, and when we call the toString method of the instance, we'll get a representation of a string. And many times this method is called implicitly. For example, if I take this date time and I put it in a console write line, it will be converted into a string and displayed on the screen. So that if I have a method like console.writeLine, I can make it call the toString of my class and print out whatever the class will return when you call this method. So we started looking at classes today and objects, and mainly the differences between classes and objects, and static and non-static, and methods and the properties, and we really just started touching the whole subject, but that's okay, because from now on that's going to be with us all the time. That's probably the most important building block of the C# language, so it's going to be with us all the time. And we've also seen some enumerations and structs, and just in a few words we mentioned the common type system, and we've seen one live demo of a real class and constructors, and that's about it for now, I guess. Any more questions right now?
Can we use one method in different classes? For example, this toString method, is it fine for one of the classes and the other class can use?
Yeah, we'll talk a lot about inheritance. And inheritance allows you to build more complex class relationships. So you can build classes which take properties and methods from other classes and without implementing them. Or if you have, for example, a child class which needs a different implementation, it can override whatever the parent class defines. So, but it can have a default implementation from the parent. And this is a whole big subject which is very tightly related to object-oriented design. And we're going to see a lot of that, but not today. More? All right. Okay, great. And it seems like we don't have much time left. So we're pretty much finished.